Welcome back. We are discussing the fourth lesson in Chapter 10 of the Pearson Geometry video series. Section 10.4 is focused on the properties of inscribed angles. As Theorem 10.8 states, the measure of an inscribed angle is half the intercepted arc. Let's look at a picture. And I showed you this in class, but if we have a central angle that's 90 degrees, it's a right angle. So the arc is 90 degrees, which matches our central angle. Here we have an inscribed angle that intercepts the same arc. But this one clearly is not 90 degrees. So this is, in fact, half of that. So this is going to be 45 degrees. Okay. Inscribed angles don't always look the same either. So in case 1, we've got the inscribed angle where one of the sides goes right through the diameter, right through the center. In case 2, both of the sides go around the center. And in case 3, both of the sides are above the center. But all of them would intercept the same arc, regardless of where they were. So even if this was moved over so it was down on both sides of it, if the arc was the same size, then it would still be the same size angle. Okay, let's take a look at the corollaries. These make inscribed angles a little more user-friendly. The first one says, two inscribed angles that intercept the same arc are congruent. Okay, so we have one of our angles is right here. And if you stare at these long enough, they move because there are a couple pairs that intersect the same arc. Okay, so we have the same arc is right here. So both of these angles, this one and this one, intercept this arc right here. So that means that both of these angles are going to be congruent. Okay, the second corollary says an angle inscribed in a semicircle is a right angle. Okay, well that makes sense, because if it's a semicircle, that means that the diameter goes right through here, which means that the intercepted arc is half of 360, or 180 degrees, which means that half of 180 degrees is going to be a right angle. Okay, and the last one. The last one says that opposite angles of an inscribed quadrilateral are supplementary, which means that angle R and angle T are going to add up to 180 degrees, and angle S and angle U are going to add up to 180 degrees. All right, let's take a look at some examples. Over here, example 1 tells us that the measure of DG is 45.6. Okay, so that is right here, the measure of this minor arc. That minor arc is intercepted by angle E right here and angle F, not necessarily in that order. Both of them intercept this arc. So if we take 45.6 and divide it by 2, we're going to end up with 22.8. So both of those angles are 22.8 degrees. Okay. Second example, we want the measure of RST. Okay, so that would be right here. So if we look at this diameter, that means that a semicircle is the intercepted arc, which is 180 degrees, then angle RST is going to be 90 degrees. Okay, last one. Measure of ABC is 184. Okay, so that means this part right here is 184 degrees. Okay, this is intercepted by angle ADC. Okay, so if this is 184 degrees, then that means that angle ADC is going to be half of that, or 92 degrees. Okay, so angle D and angle B are supplementary. So if we subtract 92 from 180, we are going to get 88 degrees. All right, we also know that the measure of arc BCD, okay, so that's going to come right around here, is 242. So this arc is intercepted by angle DAB. So half of 242 is 121 degrees. And if we subtract 121 degrees from 180, then we find out that angle C is going to be 59 degrees. So angle A is 121, angle B is 88 degrees, angle C is 59 degrees, and angle D is 92 degrees. All right, now we're going to take a look at some tangents and chords. But before we look at example 4, let's take a look at Theorem 10.9. Okay, Theorem 10.9 says an angle formed by a chord and a tangent. Okay, so here's a chord, here's a tangent, is half the intercepted arc. All right, so whatever this arc is between the vertex and the endpoint, that's the intercepted arc. So it's going to be half of, this angle is going to be half of whatever this arc is. If we know the angle, then we double it to get the arc. All right, let's take a look at example 5. So in example 5, we have a tangent in WY, and we want to know what the measure of XZ is, this arc right here. Okay, so inside this arc, it is intercepted by YXZ, which is 50 degrees. If we double it, then we're going to get 100 degrees. So we know that the measure of XZ is 100 degrees. Okay, we also want to know what the measure of angle VXW is. Okay, so VXW is right here. So if we knew what this arc was, we could take half. Now we know that this is this is 100, and we know that this is 196. So if we subtract 100 and 196 from 360, then we're left with 64, which means that this arc right here is 64 degrees. And since that's the arc that's intercepted by VXW, we can take half, and VXW is going to be 32 degrees. All right, keep in mind, when you add up all of your arcs, you get 360. So if you subtract out the pieces and parts, you're going to be able to find what's left. Okay, last 3 examples. Let's take a look at example 6. Okay, example 6 has line DF is tangent to circle Q at point E. Find the measure of EGH. Okay, so EGH is right here. And since it has the intercepted arc is inside a 72 degree angle, we can double that. We're going to say 72 times 2, which is equal to 144 degrees. All right, example 7. In circle Q, find the measure of JKL. Okay, so JKL is going to be from here to here. Okay, so we have an intercepted arc that's 49, which means, or an inscribed angle that's 49 degrees, which means that the arc is double that. So 49 times 2 equals 98. We know that the minor arc LK is 46. So if we subtract 46 from this, we are going to get 52. So the measure of JKL, since this is 52, is going to be 98 degrees. All right, last one. In measure M, find PRQ. Okay, so we have PRQ. We want this angle right here. Okay, so we want to know what this arc is. If we can find that arc, then we can take half of it in order to find this angle. Okay, so we know that this is 106. Okay, so that means that from here to here, okay, that is going to be 212 if we double it. Okay, so this is 212. And then this part, and I should highlight that a little bit more. We want this one. Okay, so this part is 82. So if we add, let's see, if we add 212 plus 82, then we are left with 294. So 360 minus 294 is 66. All right, so we know that our PQ is 66 degrees. We want to know what that angle measure is, and so we're going to end up with 33 degrees. All right, so that's it until lesson 10.5 when we add secants and segments to the mix. See you later.